Hello, I'm Spencer Kersey with Group 4, and we did our deep learning on an LSTM based approach to stock markets. So basically, why did we choose this? We chose this just because financial markets are dynamic and we wanted to see just how close we could get to the actual output data with our model. So with traditional models like ARIMA, they just have issues with temporal dependencies. Basically, the data, it doesn't understand the data has to be before others, and it gets a little confused. So we use an LSTM, which has great memory recall, and it is really good at understanding what should come before and after and understanding their relation to each other. So our data source, we used Yahoo Finance. We mainly specified Apple for most of our testing, but we did use some others. We used a 60-day sliding window, but that can be changed. Next day's closing price was what our output came to be, is what we specified. You can modify that, but just if you do change that, just remember that the longer you make the output, the more inaccurate it's going to be. So we went with an LSTM-based neural network with 3 layers. So it has 3 layers of LSTM and then 2. We also used ReLU and dropout for regularization, and then the dense layers for output prediction. So why did we use some of the things we used? We used an atom optimizer just because certain things like SGD and RMS prop, they just had issues with like second moment, like just the variance, and then also just manual tuning issues. It was just a lot easier just go with atom. Um, Although there could be other ones that are better. Just from our testing, that's what we found was the best. We also use mean squared error for our loss function, and we just use that just because it was pretty easy. It's a pretty standard one, and it also does it a lot better quadratically because it penalizes a lot better than some of the other ones, and it's also just better for the smaller errors we have. So we used around 131,000 parameters in our model, and this was consistent with just everything we did. You can see the RMSE and the MAE performance metrics we had slightly improved from our baseline, but the accuracy was quite a bit higher. You'll see later in our graphs. Um, so yeah, so here's some graphs that we got. We have our training loss over epochs, very good decrease over time, not a lot of bumps, and was very consistent. Here's our residual error. There was a few peaks here and there, but for the most part, it was a pretty good bulb, and so we were pretty happy with that. Here's also some predicted versus actual prices. We did a pretty good job, although at some of the higher values, we did have some error. Just the line wasn't completely correct, but overall, I think we did a pretty good job, and you'll see that in later. So here's the later and how much better we got from just our baseline LSTM model, which we used. As you can see, the yellow line is much closer to the blue on the right, and we are very proud of it. So basically what we did was we had a few different things that we did, but the main one we did was we included data from the S&P 500 in our training data. And so that's basically just to help understand the temperature of the market as a whole rather than just the single stock by itself. Because again, most stocks are somewhat changed by other stocks and just the market as a whole as well. So we used that and we had a great improvement, as you can see, much closer. So we did actually look into other models which we could use, such as SVM and random forest. The main issue with random forest, you can see, is not as great with these graphs, but the main problem was temporal coherence, basically meaning it would shuffle the data and it had no idea what data should come before others, which really did not bode well for the model predicting stock prices. SVM, the main problem was memory. Just it doesn't have great memory understanding. You can implement that, and we could do that, but just with LSTM having that built in, it's just a lot easier and a better choice for our use case. So why we used Yahoo Finance, the main issue was we had zero configuration. We didn't have to set up API calls in Python ourselves. It was just a Python library ready to go. Had Panda support out of the box, and also it was free and had great data available to us. Had most stocks that we can use and like 10 years of stock data that we can pull from. We did try other things like Alpha Vantage, Polygon.io, but again, they just had issues stemming from either price or data availability. So our experience, Clark was the main one that got us into the stock market. He does a lot of work in that. It was a pretty interesting thing that me and Amir Hossein really enjoyed. But we also, all of us have information and we've done work in the AI sector. I'm actually working at a company right now which does AI in the medical field. It's pretty interesting. So we went through all our next steps that we had for our baseline, and I think we did a great job of meeting our project goal and conclusion. Thank you for watching.